Okay, today we're going to do 11.6, solving rational equations. So remember, what is a rational number? A rational number is any number that can be written as a fraction. So today we're going to be solving fraction equations. So first off, I'm going to show you a couple steps before we get started. So most often, anytime with fractions, what do we need to do is we always need to get a common denominator. So even when solving fraction equations or rational equations, step one is going to be to get a common denominator. We've got to get all the denominators exactly the same. Well, how do we get a common denominator? What you're going to do is you're going to factor denominators and multiply. I spelled multiply wrong. And multiply by what is missing. Okay, so step one, get a common denominator. Step two, once you get a common denominator, well, if all your denominators are the same and the left side equals the right side, well, then that must mean that all the numerators must be equal. So after you get a common denominator, well, then equal denominators means equal numerators. So set numerators equal left side, right side, and solve for x. And last but not least, we should always check. Because just like with any fraction, our denominator can never, ever, ever be 0. So 3 steps. So let's put this into practice with an actual problem. So let's look at this first example. So solve x minus 18 divided by x equals 3. Solve x minus 18 over x equals 3. So step one is, do we have a common denominator? So notice x has a denominator 1. The second fraction has denominator x, and the right-hand side has denominator 1. So what do we need to do? We need to multiply by what is missing. So since our second fraction is 18 over x, well, what is missing from the first one? The first one is missing an x. We have a lovely rule in algebra. I can multiply the top by x as long as I multiply the bottom by x. So I'm really just multiplying by 1. X divided by x is just 1. It's just a fancy one. And let's do the same thing with the 3. So I have a 3 on the right-hand side. I need an x in the denominator. I can do that as long as I multiply the top by x. Okay, so this step is get common denominator. And in this instance, the common denominator is x. Make that a little neater for you. Okay, so now what do we have? Well, x times x is x squared. Minus 18 equals 3x. And notice we have all of this over x. This is over x. This is over x. This is over x. Well, what must be true? If something divided by x minus something divided by x has to equal something else divided by x, well, if all my denominators are the same, that means that all my numerators must be equal. So equal denominators means equal numerators. So equal denominators means equal numerators. Or you can also think about this way. If I want to eliminate the denominator, I can multiply everything by x. If I multiply everything by x, the x's cancel, and either way, we're left with our numerator x squared minus 18 equals 3x. Okay, so now we just have a quadratic. Well, if I have an x squared, my goal is to try to isolate the x. Well, since I have a trinomial here, I'm not going to be able to isolate the x without factoring. So let's set everything equal to 0. So subtract the 3x from both sides. So x squared minus 3x minus 18 equals 0. So again, we're just setting equal to 0. And next we need to factor. So because we have a quadratic, we need two answers. So parenthesis, parenthesis. We're looking for two numbers that multiply to 18 but add to negative 3. So ways to get 18 are 6 and 3. If I need a negative 3, that would be a negative 6 and a positive 3. So 0 property. If something multiplied times something equals 0, that means that x minus 6 equals 0 or x plus 3 equals 0. So if we solve for x by inverse operations, x would equal positive 6 and x would equal negative 3. Now, before we box, we need to check, okay? So why is it important to check? We need to look at the denominators. Remember, anytime we have fractions, our denominator can never, ever be 0. So let's look at 6. If I plug this back in at any point, is our denominator going to be 0? No, since our denominator is only x, 6 and 3, negative 3 are both going to work. You can box it. Again, you can also plug it in. 6 squared is 36. Minus 18 is 18. 6 times 3, 18, check. Negative 3 squared is 9. 9 minus 18 is negative 18. Or 9 minus 18 is negative 9. 3 times negative 3 is negative 9. That checks as well. So two answers for this rational equation, x equals 6 and x equals negative 3. Let's try another one. What if we have 2x minus 5 over x minus 8 plus x over 2 equals 11 over x minus 8. Let me fix this so you can see it a little better. Okay, so again, first step is we need to get a common denominator. So notice I have an x minus 8 and I have a 2. Therefore, my common denominator is going to be both of those. So again, my first goal is to get common denominator. And this time, the common denominator is going to be a 2 and an x minus 8. So if we look at the top, 2x minus 5 over x minus 8. Well, what is missing there? What is missing is the 2. We have the x minus 8. We need the 2. So we're going to multiply. We're going to multiply the top and the bottom by 2. 2, 2. Second one, x divided by 2. Well, what's missing from this one? This one has the 2. We're missing the x minus 8. On the right-hand side, well, we have the x minus 8. We are missing the 2. So distribute 2 times 2x will be 4x minus 10. Now we're just going to keep the 2 like this. It doesn't matter either way. We're eventually going to eliminate it. Distribute the x. We get x squared. X times negative 8 is negative 8x. 11 times 2 is 22. Okay, well, what do we notice? If all our denominators are the same, that must mean our numerators are equal. So equal denominators means equal numerators. So we have 4x minus 10 plus x squared minus 8x equals 22. And we're just going to solve this for x. So let's see what we combine. We have 4x and a negative 8x. So I'm going to put the x squared first. So we got x squared, 4 minus 8x is negative 4x, minus 10 equals 22. We can set equal to 0 by subtracting 22. Squared minus 4x, this will be minus 32. Again, this is just setting equal to 0. And again, we have a quadratic, so we need a parenthesis, parenthesis. We're looking for two numbers that multiply to negative 32, but adds to negative 4. Well, 32 and 4 is going to be 8 and 4. If I need a negative 4, that's going to be x minus 8 and x plus 4. So again, this is factor. And now we can use 0 property. X minus 8 equals 0. X plus 4 has to equal 0 from 0 property. If we're multiplying to get 0, then one of them has to be 0. Solve for x. We add 8 to both sides here. Subtract 4 from both sides there. X is going to equal a positive 8, or x is going to equal a negative 4. So before we box it, we must always remember to check. Now, let's look at our denominators here. Let's look at x equals 8. Let's go back. Where is our denominator? Our original denominator was x minus 8. If x minus 8 equals 0, that means x cannot equal 8. So we are going to have to reject 8. This is adios spy, reject. We must reject. Why must we reject? Because the denominator cannot equal 0. Denom cannot equal 0. What about negative 4? Can we plug in negative 4? Yes, that one does work. So box it. We are good for that one. Always, always make sure to check, okay? Your denominator can never, ever equal 0. So correct answer on this one is only x equals negative 4. Let's try one more. Let's look at this example. What if we have 16 divided by x squared minus 16 equals 2 over x minus 4? Well, here we have, this is a rational equation because we do have a fraction equaling a fraction. But because we have a fraction equaling a fraction, this is a proportion. So why don't we just cross multiply? I don't have two fractions being added at all, so let's just cross multiply. So if we cross multiply, we have 16 times x minus 4 will equal 2 times x squared minus 16. Then we can distribute. So this is 16x minus 64 equals 2x squared minus 32. And let's set equal to 0. So if we set equal to 0, that means we are subtracting 16x. And we are adding 64. So 0 will equal 2x squared. Negative 32 plus 64 is a positive 30. Actually, let's do the minus 16x first. And this would be a positive 32. Next, we need to factor. And first off, there's a GCF here. So first, they both have a GCF of 2. I can factor out a 2 from everything. So this would get you, if I factor out the 2, 2 times x squared minus 8x. 2 times what will get us 32? That is 16. Now we're looking for two numbers that multiply to 16, but adds to negative 8. So that's going to be minus 4 and minus 4. And 0 property says the 2 we don't need to worry about because that's a constant. So 0 equals x minus 4, 0 equals x minus 4. If we add 4 to both sides, here x equals positive 4, x equals positive 4. So we have 4 twice, but we must check. So let's look at that denominator. Zoop. If we plug in 4, 4 minus 4 is 0. So we have to reject. You must reject. Okay, adios amigos. You must reject because the denominator can never equal 0. Can never equal 0. So therefore, here, because we only have 2 4s, 4s have to be rejected. We have no solution. No solution.